Steve, once again, congratulations on your first place victory and first Kaggle victory in this year's NCAA tournament competition. We're excited to see what you came up with, sort of just your process of approaching this problem, sort of the story as the tournament unfolded, as things led up to it, and just hearing a little bit more about what you did, and see if others who are viewing this walkthrough can learn from it and hopefully improve their own data science ability. So I'll go ahead and hand it over to you, and I'll probably have some questions at the end. But why don't you go ahead and take things away and walk us through your solution?
Okay, sounds good. So I'll just start a little bit about my background first. I am not a data scientist, or I don't work in that industry. I'm an accountant, a CPA, and I specialize in audit, due diligence work. I think going into the detail, it's kind of what attracted me to data science, and Kaggle competitions. I've been doing a number.
I'm a recovering CPA. I was also in audit in the first parts of my career. So I think I see where the overlap and desire comes.
Yes, I don't use a lot of models, in my day-to-day work, but I do end up using Python, and pandas for work that is basic for information that's too big out, to be handled in Excel.
Sure.
Which is that's actually one thing that's super helpful to to my day job. But yeah, so I've been working on these competitions for a number of years. I've had some luck, but I took the last couple of years off. And with this competition win, I now have one gold, one silver, and one bronze medal. So just a little bit about the model. I essentially used Radar's model that has been used in many competitions since I think 2018 was the first one where he won the women's competition, and it's been used in a lot of the top performing models over the last couple of years. This is basically a summary. It's just a simple XGBoost model with just a handful of features, which the whole model itself runs pretty quick. Runs under 5 minutes. So it's a pretty simple model that has historically done really well. And just a little bit more about the features. In total, there are 45 different features used in a model. And it's basically just a sum, or just a mean of the regular season results for the team and the opponent. And there's really not much else to it. If you look at the specific features, there is one team one used follows, and team two uses blocks here, but other than that, everything is a little, it's just a standard mean for those categories. And there are a few additional calculated features. There's a win ratio over the last 14 days, which theoretically, takes into account the teams, their hotness, over the last, over the end of the season. And then there's a team quality feature, as well as there's the tournament seeds and the difference, between the seeds, the opponent. And that's really all the features that there are. If you look at the, just the effectiveness of the various features, was it 7 that really contribute most? Basically, it's the seeds, the seed difference, and then the seeds for each team, the quality of each team, and then the difference, the regular season difference in points. And there's all the other just significantly less important. And this is just another chart. This is the SHAP, the tree explainer. All this was data that I ran after the competition, because I've mentioned before, my submission was really based on a Radar's solution, and I made essentially minimal changes. I think I made 2 very, very small changes from his model that was from 2018, which I have a slide on later in this presentation. And these are just some more charts of kind of the main features, the seed difference. One interesting thing is on all of these dependence plots that the variable that's dependent the most on is the turnover category, which is one interesting aspect, which we'll see in the next couple. As well, this same plot just on one of the more one of the other main features, the team 1 point difference. And here the team 1 opponent turnover mean is the main dependent variable. Team 1 seed, kind of the same story, where the team 2 turnover mean is kind of the main dependent variable. So yeah, I don't really have a lot to say on the features, as I made 0 adjustments from the original model. And so just a little bit more, on the model, there's nothing super unique. It's a standard XGBoost model. There is a custom loss function, and it's trained on the difference in the score. And the other unique thing is the model is trained 3 times. With my submission was trained 3 times, with a different random state, and then those predictions were just averaged, which resulted in the actual submission. On the data that was used, there is a lot of data that is included in the tournament, but for the submission, it's really only the mean of the regular season detailed results is used for the features, and then just the tourney detailed results and the tourney seeds is what's really used for the training aspect. So basically, you just take the mean of the regular season data and give that to the teams that have historically been in the tournament. And that ends up with the training data of 4,016 and the 45 features. Now, a few of the interesting things in the submission. As I mentioned, this was simply Radar's code from 2018. I think in past tournaments, there's an R version that is kind of the dominant one that everyone uses. But since I don't really know R that well, I found the Python version that he had, that I think he had made it simply for a presentation. And I just kind of updated that code for the most recent tournament. And what I removed was there was an exponent calculation that was included in the team quality feature. And that was causing a lot of infinite values. And so I simply removed that, which ended up improving the model. I think I still would have been in the top 10 had I not made that adjustment. And the other thing was I removed all the overrides, so I just let however the model predicted was what I went with, as opposed to forcing wins against the highly favored 1 through 4 versus the bottom teams. Prior to my submission, all I really did was make sure that the results seemed appropriate, and just kind of went with it. I kind of ended up a little bit of dumb luck, as I don't know how much time I spent on the game overall, but it wasn't too much. It was probably maybe an hour or so. Just kind of putting everything together. So these are some of the results of Radar's code, historically. Like, he won the women's competition in 2018, and then subsequently other people have using his code have also done really well. They've won the 2019 men's, second place in 2019 women's, first place last year, and I won this year, which was the first year that it was actually combined, the men's and women's code, or the men's and women's competitions. Historically, they've been separate, but this is the first one where it's combined. And the model still performed well without any changes. There were quite a few. I think there were quite a few people this year that in the top 10. I think there was at least a handful, that used the Python code as well. So just a little bit on some of the features, and some of the differences. This is, I guess, my actual contributions, to the winning model, without taking on. So basically, at the exponent calculation here, removing that, my winning score was the 0.17371. But had I left it as is, I would have ended up as sixth place, a little bit down. And the reason I did that was just looking at the actual submissions. There was a lot of infinite values. And I was able to trace that back in the code, and I just commented it out. And there was I didn't go through and truly understand everything related to it, but I figured having a value as opposed to an infinite value, could only be helpful. And also related to team quality, looking back at the submission, this was actually only being calculated from 2010 and on. And this was done originally, I think, because that was when how far back the women's data went in the 2018 competition. But there is more historical data there, going back to 2003. I think that, I don't know if that's only for the men's data only, but if I include the team quality calculation for that, I went back and did that subsequently, and it improved the model considerably. And here's one. This is kind of the same tree explainer plot that I had shown previously, but this shows the features where the seeds are close, where there's basically no difference, where there's only one, so 1 versus 2, would be included here, but a 2 versus 4 seed wouldn't be. And the same 7 features, I think it was 7. They're the most important, to any way you look at it. But looking at the games where the seeds are closer, the team quality becomes a little more important. So that feature does help, on the close games, which is interesting to know. So there is, as I mentioned, I didn't spend that much time working through the actual model, prior to submission. But after the fact, I've kind of gone through and made some changes. And there was several. I tried a couple things, and each case that it improved the submission quite a bit. this was the winning submission, the 17371. If I, instead of repeating the model 3 times, if I repeat it 10 times, it improves quite a bit. Same thing if changing the loss function a little bit, that improved it. If removing the team quality feature, does make the model a little worse, but it still ultimately would have been first place. And not something I included here, but in these presentations, but I did go back and just try a different combination of the features as opposed to the ones that were specifically, selected from the 2018 model. And if I just include a mean of all of every feature, the model does perform quite a bit worse, but I think it still would have been, like the last to gold spot, so around 10 to 15th place it would have got, so the feature selection from the 2018 model is, significantly improves the score. And I think that's all there is to the presentation.
Thanks, Steve. Yeah, that's really great. Are you a basketball fan by chance? Is that what kind of brought you into this, or is it more just general? This is the type of data set that was approachable for you.
I am a basketball fan. I did not follow much this year. So, but it's always the March Madness. The tournament is always one of the most exciting sporting events of the year. Just due to all the upsets.
Right.
And I live in a college town. It's a team that's always in the tournament. So it gets a little more always interested in it. For sure.
Did you do any reflection on your model as the tournament was unfolding to see if there are particular features this year that were more representative than maybe in the past? So, or maybe the way I look at it is saying, the model is trained off of previous year's data, but we know that the game of basketball is continually improving, such that, for example, Steph Curry's dominance in the NBA has drawn a lot more three-point shooters in colleges and in their upbringing. And so that may make more of an importance on three-point shots in college basketball or something like that. So as the game develops, perhaps features develop more, or as the tournament develops, perhaps there is teams that are more high scoring are doing better than those who are stronger defense. Did you by chance get a sense of maybe how this year's tournament maybe leaned more heavily towards one particular feature than it did in previous years?
So unfortunately, no. That is something I am hoping to do because this year obviously there was a lot of upsets.
Yeah.
But I think my gut feeling is that since the men's and the women's were consolidated this year, the women's competition is going to be more. There's going to be less up. There's historically less upsets. So I would assume that kind of balanced things out a little bit. Because if I think I entered these, the same winning predictions on kind of like the main ESPN, predictions, and the women's side ended up, I think, at the 99th percentile. Well, on the men's side, was the 50th percentile. Well, obviously the scoring's a little bit different.
Right.
But I think
all or nothing.
Yeah. Yeah, exactly. But I think adding the women's side this year, combining that mix, I think that made a big difference, and probably helped out a lot. I doubt my model would have won, or Radar's model here would have won, just on the men's side alone.
So I'm curious, obviously we combined the two tournaments this year. I see, in your profile that you've entered in tournaments in the past. Plenty of machine learning competitions, but even a couple of the basketball tournament competitions. Did you change anything to your model this year over the previous years?
Yes. Previously, I spent quite a bit of time, going through features. I had made my own models. I think I used a lot of the regular season data as opposed to sticking to the, just the tournament. Just instead of using the teams that are in the tournament, only in the tournament. So you end up with, 4,000 or so, training data. You would end up with, significantly more because you use all the regular season. That was one big difference. That just didn't work out well for me, and I think most people just use the they don't use a lot of the regular season training data. I think they kind of default to just the teams that are actually in the tournament.
Yeah. I know as well, something that I believe Radar's model originally being on the women's tournament, and as you mentioned, historically doesn't have as many upsets. He would overwrite or basically do some post-processing for 1 through 4 seeds, and he just said they're going to win. We know that's not nearly as true or as true as often in the men's tournament, and even this year, second time ever in history, 16 seed over 1 seed. Do you maybe walk me through your decision to remove those overwrites? I know we changed the metric this year, which therefore didn't penalize you as much for those big extremes. And in previous years, there had been some strategy as to, did you want to round up your model to 3 or 4 more decimal places, but also have a massive punishment if you were to be wrong? Maybe kind of walk me through what your thoughts were with sort of that post-processing decision.
So really, I just wanted the model to make the predictions. There was really nothing more, nothing more than that. I just, I felt more comfortable that way. That probably worked in my favor. I'm assuming instead of forcing, that upset, I don't know exactly what my prediction was there, but I'm assuming it was because it does use a clip. I think it forces it to 0.025, or
right.
The highest winning percentage I think is maybe 0.975 in my model. So instead of forcing that to 100%, when there was that big upset, probably definitely helped.
Yeah, and we've seen some years where the entire tournament basically is thrown, or the leaderboard on Kaggle at least is thrown for a loop because people they clip their, or they choose not to clip their predictions and way too heavily in favor of the top seeds, and forget that there's a whole reason why it's considered madness, and it kind of penalizes them. Would there be any other types of data sets that you wish you would have had, or in the future would be interested to sort of test and see how it may impact your model?
So one of the bigger things is, just the team quality calculation. There might be better ways to do that. I know a lot of people replace that. I think there's I think it's the 538 ratings. Mm-hmm. Or what I forget exactly what they're called, but there's the team ratings out there. Yeah. I don't know how if using those, in place of that simple team quality calculation, would have helped. Because I know the Python version is different. It's calculated different than the how it's originally intended. Because in the R version there's a random effects to it. But that's not included. I don't believe that's included here in the Python version. So I think that could definitely be improved. Just some way to rank the teams.
Right. Well, I mean, this is great. We're always excited to see how Radar's work from years ago continues to do well. And obviously you're adding a little bit of tweaks to it. The idea being that many people use the same code, and it's just that your particular flavor of it was the one that rose to the top. So don't sell yourself too short for your additions here. I don't have any other particular questions. Do you have any other questions for us at Kaggle?
I don't think so. One question or one comment I should add though is, when I was following through it was very fun and interesting to follow through with everyone, in the discussions on the discussion board as the tournament was going on. Because I think essentially we kind of determined that going into the championship games, it really all depended on the women's game. If LSU won, I had a really high chance of winning. But if Iowa had won, I think someone else would have been the likely winner. So that was pretty entertaining to be able to know that going into the games.
It's a unique format of our typical machine learning competitions because the ground truth doesn't exist yet, and there's also not really a risk of, once the submissions are locked, of sharing what everyone's predictions were. So you can kind of play along with yourselves in the threads and sort of see, like, it then gives you an investment in random games that maybe you wouldn't have otherwise been invested in.
Yeah, definitely.
Yeah. Well, Steve, thanks again so much. We're glad to have your walkthrough here and your presentation contributing to the Kaggle community, knowing that one of our things, the Kaggle community, and loving having public notebooks, is just knowing you don't have to start with a blinking cursor, and you can jump into something and kind of say, oh, well, maybe I can improve it here or change it here. And a lot of times that's what makes the collaborative community of Kaggle and the data science world great. So congrats once again. Great victory. Hopefully we see you again in the future. I know right now being a top 50 ranked Kaggler is by no means any small feat. And we'll see if you can maintain that position in competitions to come. And we're so excited to see what you come up with next.
Yeah, thank you. I appreciate it.